This video will hopefully convince you that bottom-up obstruction happens just like the globe model predicts, and that flat earthers who say otherwise are just cherry-picking observations and fooling themselves and others. So, here I'm showing all the information for observation 30, which is an observation I did across the ocean. I'm getting the distance to the target and the target elevation. The elevation is 157 meters, and the distance to it is 61.882 kilometers. And then here I'm showing that we did pick the highest point, give or take a meter. Alright, here's LiDAR data showing my elevation. Add it all up, you get 10.56 meters viewer elevation. And then we plug it all into a curve calculator, and even with standard refraction, the whole target should be hidden by the ocean. But here we see the 157 meter tall target, even though, and when we see Backloo Island to the right, even though it should be all hidden. So does this mean Earth is not a globe? Well, let's look into this a bit. Let's do a blink test. Notice how the shape isn't quite right. Compared to the reference, what we see in the video looks squished vertically. That's an indicator of stooping refraction, aka atmospheric compression as Mick West referred to it as, which is caused by temperature inversion. Basically, light is bending more sharply around the curvature of the Earth, allowing us to see what would otherwise be hidden. And just in case you were wondering, I really was where I said I was. So now notice how when we go down in elevation, the target becomes more obstructed. So the hidden height increases as elevation decreases. And that I can tell you what I saw here is an exception to the rule. I cherry-picked this, just like a flat earther would cherry-pick a day with high refraction. And we can see here, even from like 2 meters elevation, we can still barely see the tip of the target there. So flat earthers might call that 58 meters of missing curvature. I would just call that refraction. And they'll show you why. So, but first I'll just quickly show like a side-by-side of all the observations for day 30. And here's what we typically see. So from a low elevation, everything will be hidden, or you might just barely see the tip of the target, but then from a high elevation you'll see this giant target staring you right in the face. So like the bottom-up obstruction is very clear. So how do we know that the observation done on day 30 was a result of refraction? Well, the first thing we want to do to answer that question is to collect as many data points as possible and then just have a look at them. So in the white column there, I just show day 1, day 2, day 3. These are all the observations I have recorded. And you can see that I have 46 observations recorded in total. So these first 2 columns here, in blue, these are just observations on a date used to confirm atmospheric visibility was sufficient. So in the gray rows here, that just means that the day was too hazy. So 46 minus 4 is 40, leaves 42 useful days. And here's the observations from those days. So I basically recorded whether or not I could see a target from the given vantage point. And the end result of that, I just compiled all the data together, and in the red row, this is the number of times that the observation did not match the prediction of the globe with standard refraction. And the green row is the number of observations that did match the globe with standard refraction. We have more data points from this elevation point, which is basically the same as this one, so we'll just start here. So from the car in the parking lot, half the time we matched the prediction and half the time we didn't. And the hidden height is about the height of the target, so that makes sense. Like sometimes refraction lets you see a little bit farther, sometimes it doesn't quite let you see as far, so it makes sense that it's about half and half. Then as we go down in elevation, where the predicted hidden height is 194, 28 days we matched the predictions, and 5 days we did not match the predictions. And then down from the very lowest elevation, about 2 meters, standing at the shore, we had 33 observations agreeing with the prediction of a globe with standard refraction, and one day 30, did not agree with the globe prediction with standard refraction. So, like, which model better explains the observations? Well, clearly, a globe with standard refraction has 33 agreements and 1 non-agreement, and flat Earth would have 34 anomalies. 0 observations would be in agreement. So clearly the globe model with refraction being variable is the better model to explain these observations. Here's a laser test done by flat earthers. These numbers are entirely possible, but this picture paints a lie. It makes it look like the beam went in a perfectly straight line. Estimating the initial and final diameters suggested by the picture gives a beam divergence of 1.3 microrad, which is 3 orders of magnitude better than a typical laser beam. I think it's pretty obvious that they shone a laser from behind the camera to make it look like there was no refraction. However, as my data shows, a large amount of refraction can happen on rare occasion, and of course experts will tell you that the curvature of a light ray can equal or exceed the curvature of the Earth. So, yeah. Also, what we never get with laser tests is a properly sampled set of observations like I have. Flat earthers just show one observation. So why haven't flat earthers picked a laser, figured out the maximum distance it can be seen from, and then put the laser 1 meter above the water and observe it from the maximum distance at 1 meter viewer elevation? Why don't they have a huge collection of this observation repeated day after day? I was able to get 42 good visibility days by now, and I haven't been trying very hard. I'll tell you why the flat earthers haven't produced this large collection. They are cherry-picking observations instead of honestly and unbiasedly collecting a large amount of observations. If the Earth were flat, then bottom-up obstruction would be rare. Having seen over 137 meters of bottom-up obstruction on 42 out of 42 days in my data set, rules out flat Earth, and it strongly points towards a curved Earth.